am Shawn Alair. I am assigned to the drawing part. So I first did some sketching. Then, after all that sketching, at the end I have an idea. So first is I draw where the egg is wrapped around the manila paper, and after drawing the bottom part is I draw the upper part, which is the other manila paper, and I did sketch it a lot because it's so hard to do it symmetrically. Then after completing the top part, I did the strings, connect them to the bottom. Then at the end, I did some coloring and have the different parts zoomed in or emphasized. That's all.
Hello, my name is Ayeizha and I have been assigned as a theoretical engineer for this group. It is my responsibility as a theoretical engineer to describe the scientific principles underlying the prefabricated device or parachute. The capsule and the parachute are the major components of this apparatus nowadays. With the aid of yarn and tape, the concave-shaped parachute that is positioned on top is fastened to the capsule. The form of the parachute substantially reduces the air resistance of the entire apparatus, assisting with the slow and smooth landing of any object it holds. In addition, the parachute makes use of its final velocity, and of course, gravity drags the apparatus downward until it touches a surface. The capsule is the device's second component. The aforementioned apparatus, which will be represented by an egg with an extremely brittle shell, will be contained inside the capsule. The capsule naturally has its own weight and mass, which would significantly affect the entire device. To sum up, the entire apparatus depends on physical variables to function as intended, which involves the egg not breaking in different heights to be cut from.
Hello, my name is Vincent Lex Depositario and I have been assigned as a material engineer of our group. I'm in charge of examining the supplies needed to manage this activity. Manila paper, yarn, and tape are the items we use to make our invention. The parachute's canopy was made of manila paper and the axis was used to wrap it and secure it with the weapon. The arm is the second material. It served as our parachute suspension line. The canopy and the protective bioweapon were connected by the yarn. The extra was also utilized to encase the egg. Last but not the least, the tape was utilized to firmly wrap the bioweapon and connect all the components of the gadget.
I am Jarzeth Ann Quinto, assigned as a mechanical engineer. Our structure was constructed of manila paper, tape, and yarn. The pathogen is enveloped in all three substances to make the visual content durable and prevent further damage. The pathogen is also attached to an awning, which lessens the pressure of the fall when it strikes the floor. Segments are adhered at the awning, and the tape is used to prevent components from moving during the approach. Therefore, the pathogen is insulated and any deformation is avoided.
I am Aizobelle Mana-ay and I am the disaster and risk engineer for this project. As a disaster and risk engineer, I ensure the safety of everyone. I make sure that the materials being used are durable materials and not hazardous to the people and the environment. I also made sure that the experiment is executed properly and done safely, and the experiment is well secured and the object will safely land on the ground with the help of our protective device. As a result, This experiment is done without causing any harm to the people and the environment.
Hi, I am Khrizel Villalobos and I am in charge of the construction and aerospace engineer in our group. I was the one in charge of constructing our parachute and making the device. The first thing that I do is to get one half of Manila paper, then I fold it into two types of folding. I also equalize the shape of the parachute. I wrap the egg with the excess of Manila paper, tape, and yarn. I made sure that all of the egg was covered enough by the Manila paper. I tape the yarn at the ends of the parachute and also tape it at the bioweapon. I checked and adjust the length of the yarn and see if it is balanced. Here is the result of it. Part 3. Testing of the prototype at varied heights. Testing at 1 meter. The outcome of the egg on 1 meter was not broken. Testing at 2 meters. As you can see, I am a bit hesitant to drop it. But surprisingly, the egg was not broken. But later I found out that it has a little bit crack on it. Now I'm going to drop the egg from the second floor. As you can see, I'm opening our bioweapon. I'm removing the tape, yarn, and Manila paper. I'm a little bit nervous of the outcome of it. Surprisingly, the egg was not broken at all. Although the egg has a little bit of damage, but it was not broken at all. So what can I say is that our experiment was successful. Thank you for watching.